Reinforcement stirrups, often called ties or links in construction, function primarily to hold the main longitudinal reinforcement bars, rebar, in place within a concrete structure, providing lateral support against shear forces and preventing them from buckling, thus enhancing the structural integrity of beams and columns by resisting twisting and bending stresses. Before I venture more about stirrups, I take this moment to urge you to subscribe to my channel for more construction basic knowledge. Let's look at key points about stirrups. Shear resistance. Their primary function is to resist shear forces acting on a concrete member, especially in areas where diagonal cracks might occur. Lateral support. They provide lateral confinement to the longitudinal reinforcement bars, preventing them from buckling under compression. Closed-loop design. Stirrups are typically formed as closed loops of steel rebar, which allows them to effectively distribute forces around the main reinforcement. In this experiment, let's see how shear failure occurs in beams in the absence of stirrups or links that help the concrete beam to counter the shear failure.
Beam containing no shear links being tested in bending. The testing rig is now starting to apply vertical loads to the specimen, and the beam starts to deflect. Then quite suddenly, we have an explosive failure near a support. This is what we call a shear failure, and it is something that we always want to avoid. If we slow down the footage, here is that failure again. Look how sudden it is. Now remember, this is a beam in which we have left out the shear reinforcement, and this is the consequence.
To account for higher shear loads near the support, stirrups are placed closely together, ensuring that several of them will be engaged within an inclined crack. Near the middle of the beam, where the shear forces are low, designers might reduce the spacing or completely eliminate the stirrups. Stirrups are closed loops of reinforcing steel used in concrete beams, columns, and other structural elements. These loops are typically made from high-quality TMT, thermomechanically treated, bars and are placed perpendicular to the main reinforcement. Their primary function is to resist shear forces and prevent shear failure in concrete structures. Benefits of stirrups. Shear strength enhancement. The primary benefit of stirrups is their ability to significantly increase the shear strength of concrete members. By distributing shear stresses, they prevent sudden and catastrophic failures. Improved stability. Stirrups provide lateral support to the main reinforcement bars, enhancing the overall stability of the structure. Crack control. By limiting the width and spread of cracks, stirrups help maintain the structural integrity and appearance of concrete elements. Load distribution. Stirrups assist in evenly distributing loads throughout the structure, reducing stress concentrations. Confinement of concrete. In columns, stirrups confine the concrete core, increasing its compressive strength and ductility. Durability. By controlling cracking and enhancing overall structural performance, stirrups contribute to the longevity of buildings. That's all about function of stirrups.